Now we're going to investigate how regioselectivity comes into play during elimination. Once again, here's the overall elimination reaction. Regardless if it's E1 or E2, it has the same overall reaction. But now let's look a little closer at what happens when you have more than one type of beta proton. Here, if we label this carbon alpha with the leaving group, you see that we have a beta carbon this way and this way. And the proton here is not the same as these two protons here. If we remove the beta proton at this position, we would get the product that's shown up here. So if you can imagine, this is alpha. What we're looking at here is the alpha beta double bond that formed between these two carbons. If we remove the proton at this beta position, we would get this alkene, where you can see that this is the alpha, and this is the beta, and here are the two methyl groups hanging off the bottom down here. Notice that if it follows the pathway by removing one of these yellow protons, you get a di-substituted alkene as the product. Where if it removes one of the orange beta protons, you get a tri-substituted alkene as the product. Since we know that tri-substituted alkenes are more stable than our di-substituted alkenes, we actually will get a mixture of the two, but the majority of the product will be the tri-substituted. So we're going to say that this is the major product, and this would be the minor product. And what we're looking at here is an example of what's called Zaitsev's rule. To kind of paraphrase Zaitsev's rule, if an elimination can yield more than one alkene product, the most highly substituted alkene product will be the major product. Zaitsev's rule is an example of something that we call regioselectivity. And we say that a reaction is regioselective if it yields one constitutional isomer over another. You can see that both of these products are isomers of C6H12, but we are preferentially getting the tri-substituted product over the di-substituted product. And so this is an example of regioselectivity. To get the major product, the proton was removed from this carbon here, which is actually the more highly substituted carbon of the two. This carbon up here is only secondary, and this carbon here is tertiary. An exception to Zaitsev's rule is when you use a strong bulky base to do the elimination, so like an E2 reaction. Recall that T-butoxide has this structure, which is quite bulky. And instead of going after the sterically hindered proton, if you subjected this alkyl halide to T-butoxide for the elimination, it would actually go to this proton here. And you would get the this isomer, which was the minor product before. To summarize, Zaitsev's rule is always followed during E1 or E2 elimination to give the more substituted alkene, unless a strong bulky base is used for the elimination. And this would really only apply to the E2 reaction.